Hi, this video is dedicated to finding limits using L'Hopital's rule. This one is only going to address 0 divided by 0. L'Hopital's rule is the one that you can use with various situations. That's not the only indeterminate form that there is, but this is the only one we're going to look at. But what happens is when you get an indeterminate form, you may not get a situation when when you can use algebraic methods like rationalizing or dividing out, and you're going to have to use other things. So if you look at this example, if you put 0 in for x here, you're going to have 0 divided by 0, right? And this is what we consider to be an indeterminate form. So what does L'Hopital rule says? It tells you that if you have the limit that you're trying to find of some function f of x and some function over some function g of x as x approaches some value of a, and what we have here is, in our case, f of a divided by g of a is going to give you 0 divided by 0. We do need for f and g to be continuous and differentiable. Well, as long as it's differentiable, it's going to take care of continuity. Which we do. Both of these functions are the differentiable functions. So what you can do then is you can make this equal to the limit as x approaches a of f prime of a divided by g prime of a. Please, please, please be very careful. This is not the derivative of the function that you have there. It's the derivative of the numerator divided by the derivative of the denominator. Okay? So how does this work here? We're going to have the limit as x approaches 0. Since we have indeterminate form, we can do it. So we're going to do e to the x minus 1 prime divided by x prime. So we're going to have limit as x approaches 0. The derivative here is going to be e to the x. Derivative on the bottom is 1. It is no longer in an indeterminate form. This is, you can substitute 0 and the answer is going to be 1. I do need to mention, it is extremely important, you cannot use L'Hopital's rule if it's not in indeterminate form. So if you don't have 0 divided by 0 or any of the other indeterminate forms, you're not allowed to use L'Hopital's rule. It is not going to work. Next problem. Limit of ln x squared divided by x cubed minus 1 as x approaches 1. So if we substitute 1 here, we're going to have 0. Substitute 1 here, we're going to have 0. It is 0 divided by 0. Which means you can use L'Hopital's rule. So what we're going to do is we're going to take the derivative of ln x squared. That is going to be 2x times 1 over x squared. Find the derivative of x cubed plus minus 1, which is 3x squared. So we are going to have limit as x approaches 1. We're going to have, in this case, 2 over x divided by 3x squared. And if you substitute 1 now, you have no problems. You are going to have 2/3. Okay? The limit as x approaches 0 of sine x over x cubed. This is 0 divided by 0, which means it's eligible for L'Hopital's rule. So then we're going to have the limit as x approaches 0. Derivative of sine is cosine. Derivative of x cubed is 3x squared. And unfortunately here we are going to have a problem because cosine x is going to give you 0, but you still have 0 on the bottom. So in this case, L'Hopital's rule is actually not going to help you, and we can't really find that limit this way. So I did want to show you that so you can understand that there are situations like that sometimes. Alright, so it's inconclusive. Let's take a look at example 4. Limit as sine squared x divided by 3x squared. So as it stands right now, it is going to give us, actually, you know what, it is a mistake. It's supposed to be x on the bottom. I apologize about that. So 3 sine squared x divided by 3x squared. So if we take the derivative here, it is 0 divided by 0, first of all, as it stands right now. Take the derivative of sine squared x, you're going to have to use chain rule there. This is going to be 2 sine x times cosine x divided by 3. And if you substitute 0 into this now, you are going to get 0. You can use L'Hopital's rule more than once. If you differentiate the numerator and denominator and you're going to end up with 0 divided by 0 again, you can continue doing that. Here is a problem that I have. So some g of x is a twice differentiable function. G of 0 is going to equal to g prime of 0 and it's going to equal 0. And g double prime of 0 is 7. And we have this limit that we want to find. And it's going to be the limit as x approaches 0 of g of x over 4x squared. So as it stands right now, it is 0 divided by 0. So I'm going to differentiate the numerator and the denominator. So it's going to be g prime of x divided by 8x. But if we look at this, we know that g prime of 0 is 0. And the denominator is still 0. So what I need to do is differentiate it again. So, and I can as long as I know it's still in determinant form. So this is going to give me g double prime of x over 8. And now we are probably good because g double prime of 0 is a number, but the bottom, most importantly, is not 0. And our answer is going to be 7 over 8. Okay? So I hope this helps.